Hi, welcome to geometry class. Today our lesson is about parallel lines and angles. So we're going to start with some vocabulary today. I'm going to use my ruler and I'm going to draw a pair of parallel lines by tracing the top and the bottom of my ruler. And then I'm going to take that same ruler and draw a line that crosses both of these parallel lines. So my parallel lines, all the lines are going to have arrows on the end because they do go on forever. My parallel lines, I'm going to put extra arrows on. That indicates symbolically that they are parallel lines. Now, I'm going to letter my angles A, B, C, D, E, F, G, and H. Now, I want you to know that a line that crosses two or more other lines is called a transversal. So these parallel lines are crossed by a transversal. And now we're going to talk about some different angles that you see here. The first kind are vertical angles. And we have learned that vertical angles are congruent. And you have learned that that is a pair of angles that are formed by intersecting lines. They're across from each other, they share only the vertex point, and they are the same size. So in this picture, you can see angle A and angle D are vertical angles. They are congruent, both obtuse. Angle B and angle C are also a pair of vertical angles. Angle E and angle H are vertical angles. And last, F and G are vertical angles. They are congruent, same size, same shape. Okay, next we're going to move to linear pairs. You have already learned what a linear pair is. Linear pairs add to 180 degrees. They're supplementary. They share a side. And with their non-common sides, they form a straight line. So they make a line. Okay, so if you take a look at this picture, we have a linear pair A and B. Also, C and D. E and F. G and H. But wait, that's not all, there's more. Angle A and angle C also share this side and make a straight line along this transversal. So A and C are a linear pair. B and D are a linear pair. E and G are a linear pair, and F and H are a linear pair. So there are 8 linear pairs in this picture. Now, those two vocabulary words were ones we've learned before. The next two are new. Actually, all the rest are new. So the next one is corresponding angles. And corresponding angles are congruent. And the way that you find them is that they are located in matching places on each parallel line. So let me explain what that means. In this picture, there are two parallel lines. Angle A is in the top left of the upper parallel line, and angle E is on the top left of the lower parallel line. So since this is top left and this is top left, those are congruent and they are called corresponding angles. So A and E are a pair of corresponding angles. Now, B is on the top right and F is on the top right. So B and F are another pair of corresponding angles. They are congruent and they're located in matching places. Angle C and angle G are another pair of corresponding angles. They are congruent. And the last pair of corresponding congruent angles are D and H, bottom right of each respective parallel line. So D and H are corresponding angles. And that completes all of the pairs of corresponding angles. Next, we're going to talk about alternate interior angles. They are congruent, and you will find them in between the parallel lines because this is considered to be interior of the parallel lines. Remember, the word interior is kind of like inside. If you're in the interior of your home, you are inside of your home. If you're in the interior of your classroom, you're inside of your classroom. So the interior angles are the ones between the parallel lines, inside of them. Now, the word alternate means that they are on opposite sides of the transversal from each other. But angle C and angle D are not alternate interior because they are not congruent. Angle C is acute, angle D is obtuse, okay? So the alternate interior angles are C and F. They're kind of like catty corner from each other. So C and F are alternate interior. And then the other pair is D and E, okay? C and F, D and E. All right, so we talked about what's the interior. Outside of the parallel lines is the exterior. So we've got exterior angles beyond the parallel lines, above the upper parallel line, below the lower parallel line, okay? So the next vocabulary word is alternate exterior. And these are also congruent angles. Okay? So, angle A is exterior. Which one is alternate exterior with angle A? It's angle H. These are on catty corner outsides of the parallel lines from each other. They're both obtuse and they are congruent, A and H. And there's one other pair of alternate exterior, which is B and G. B and G are the last pair of alternate exterior angles. They are congruent. And our next vocabulary word is consecutive interior. Consecutive interior angles are supplementary, which we talked about with the linear pairs, means that they add to 180 degrees. So these are also interior angles, but instead of being alternate sides, they're on the same side of the transversal. So angle C and angle E are on the same side of the transversal and in the interior of the parallel lines. C and E are consecutive interior. C and E add to make 180. So we're going to write C and E. There's one other pair of consecutive interior angles. Those are angles D and F. They are on the right side of the transversal, the same side as each other, between the parallel lines. One is obtuse, one is acute. They add up to make 180. So we've got D and F. That's the last pair of consecutive interior angles. By the way, they don't have to be one acute and one obtuse. If these were perpendicular lines, they'd all be 90-degree angles. We kind of talked about that in our last unit. But these are often found to be in a obtuse and acute arrangement frequently in these problems. So you'll see that commonly. All right, so our next problem is right here. We're going to talk about when two lines lie in the same plane and do not intersect, they are called parallel. Lines that do not intersect and are not coplanar are called skew lines. So skew lines might be like one is going along the page and the other one is coming up off the page towards you in 3D space. They still will not intersect, but they are not parallel because they're not in the same plane. Those are skew lines. So let's look at some pictures and we'll use some definitions and figure out some things from this. It says, refer to the figure at right to identify each of the following. Number 1, all planes that intersect plane OPT. Okay, plane OPT is the right side of this rectangular prism that looks like a box. Okay, so which planes intersect or touch or come into contact with this plane on the right side? Remember, we name planes with 3 letters. Even though it has 4 letters, we could choose any 3 letters to name it with. So this front plane looks like it comes into contact with it at PS, so I could call it MPS, RSP. Any 3 letters is fine. MPS, I'll call it. The top plane, MPO. The back plane, NOT. And the bottom plane, RST. All 4 of those planes intersect plane OPT. Number 2, we need to name all segments that are parallel to NU. So see this one going up and down here, NU? Which ones are parallel to that? How about OT? Segment OT, segment MR, and segment PS. Those are parallel to NU. Next, we need all segments that intersect segment MP. So here's segment MP. I want to know which segments intersect or touch MP. So we could say NM, OP, MR, PS, and then what about this one, MS? Okay, next we're going to go down and look at this picture to work these problems. It says all segments parallel to QX. Okay, so where is QX? That's this one over here. So which ones are parallel to QX? Well, this one above it, NE, and then MH. Oops, sorry, I wrote the wrong thing. MH, TO, SG, and RA. All right, all planes that intersect the plane MHE, that's this top plane. So which planes intersect or touch that one? Well, there's one on the left side, TMH. There's one in the back, NMT. There's one on the right, NEX. One in the front, OHE. And one in the back, TMN. Did I get that right? Oh, I did this one twice. Yeah, I thought there was one too many. OHE. TMN and NMT is the same one. Apologize for that. Okay, next we've got all segments that are parallel to QR. So this is segment QR. Which ones are parallel to that? Well, there's one right across from it here, XA. That one is parallel. This one up here, OH, also is parallel. And this one, MT, is parallel. They all could be drawn in the same plane and not intersect. Okay. Now, this one is lengthy. All segments that are skew to AG. So where is AG? That's this bottom front segment. We want to know ones that are skew. So they can't be in the same plane. So they would not be on the bottom or the right or the left or the front planes from this bottom plane. But what about something like QR? QR, if we extended it forever, would not come into contact. You need to think of this as a 3D drawing. I know it's sort of difficult, but QR would not intersect it. What about ST? ST would not intersect it. It would be skew to AG. How about MT? MT is another one. How about NQ? NQ is another one. QX is another one. OT is another one. NE is another one. And MH is another one. There are quite a few. And what makes that problem challenging is that it says to name all of them, because it's easy to find one or two. It gets more challenging to find them all. Okay. Now, I've already introduced these words: interior angles, alternate interior angles, consecutive interior angles, exterior angles, alternate exterior angles, and corresponding angles to you. So we're going to refer to this picture right here, and we are going to do number 1, 2, and 3 based off of this picture. So it says identify the transversal connecting each pair of angles. Angle 9 and angle 13. So I look at 9 and I look at 13 and say, which transversal goes through both of these angles, makes up a side of both of these angles? That would be a transversal Q. Now number 2 says angle 5 and angle 14. Which transversal connects those two angles? That would be transversal L, line L. And number 3, angle 4 and angle 6. Which transversal connects angle 4 and 6? That would be transversal P, line P. Okay? Now, at the bottom, this is a little bit difficult to do because I have to show the picture and the problem. We're going to just do 4, 6, 9, and 11 here. Number 4 says, classify the relationship between each pair of angles as alternate interior, alternate exterior, corresponding or consecutive interior angles. Angle 1 and angle 5. So I'm looking at the picture. Angle 1 and angle 5. What kind of angles are those? Upper left, upper left. Those are corresponding angles. Number 6 says angle 2 and angle 8. So if I look at the picture, 2 is upper right, 8 is lower left. Notice they're both in the exterior of these parallel lines. 2 and 8 are called alternate exterior angles. They are congruent. Now let's look at angle 4 and 6. 4 and 6 are both on the interior of the parallel lines, but they're on opposite sides of transversal P. So these are alternate interior angles. And the last one we're going to do is number 11. 11 and 14. Look at angle 11 and angle 14. These are both on the right side of the transversal Q and between the parallel lines. That's called consecutive interior angles. Consecutive interior. Those add up to 180. Okay, moving along. We're going to look at these problems down here at the bottom. It says in the figure, angle 9 is 80 degrees and angle 5 is 68 degrees. Find the measure of each angle and then tell which postulate or theorems you used. So when they say tell which theorem or postulate, they're wanting you to state which kind of angle pair you used to come up with that measurement. So on number 7, notice that it is vertical to angle 5. Oh wait, that's not angle 7. Sorry, I jumped ahead. Angle 12 is what we're trying to find first. Angle 12 is right here. It's underneath angle 9. They share a side, they make a straight line. That's called a linear pair. They're supposed to add up to 180. That one's 80, so this one would have to be 100 degrees. So I'll go ahead and write that in since we know that now. We can use angles we found also. So on number 8, it wants us to find the measure of angle 1. Okay, notice it's upper left, upper left. These are called corresponding. Angle 1 is corresponding to angle 9. So we're going to go corresponding. If you'll remember, corresponding angles are congruent, so the measurement is 80. Okay, now let's go on to angle 4. Angle 4 is just underneath angle 1. That's a linear pair. They share a side, they make a straight line, and so they add up to 180. So it would have to be 100. Another way that you could have thought of it, though, is corresponding to angle 12. Corresponding angles are congruent, so you could call it a corresponding angle to angle 12 and call it 100. It's 100 either way. And there's more than one correct answer on some of these for which theorem or postulate you used, for which vocabulary word you used. So I'm going to say that this is a linear pair. Actually, I'll go with linear pair with the one above it. All right, number 10, angle 3. Angle 3 is right here. It's vertical to angle 1, so those have to be congruent. So I could say it's 80 because it's a vertical angle. Another correct answer would have been to say it's consecutive interior with angle 12. Those two have to add up to 180. Now angle 7 is vertical to angle 5, so it has to be 68 degrees like angle 5. And angle 16 is consecutive interior with angle 7. Those two are supplementary. They have to add up to 180. So we go 180 minus 68, which gives us 112. So it's 112 degrees. And that's because it is consecutive interior with angle 7. Okay. On the back, it says, find the value of the variable or variables in each figure and explain your reasoning. So we're going to do 1, 3, and 5 on this page. So number 1, we have parallel lines marked with the arrows, and this is the transversal. So if you notice, 5x minus 5 is the upper right of this upper parallel line, and 4x plus 10 is the upper right of the lower parallel line. Those are called corresponding angles, so they must be equal, they must be congruent. So we can write 5x minus 5 equals 4x plus 10. Now we solve this equation for x. We need to get the x's together on one side of the equation and the constants, the regular numbers, together on the opposite side of the equation. I like to start by getting my x's together first and then get my constants together on the opposite side. And I like to move the x's to whichever side has the larger x. So since 5x is bigger than 4x, I'm going to subtract my 4x from both sides. So 5x minus 4x is 1x. And now I'm going to get the x by itself, so I'm going to add 10 to get it to the opposite side. I'm sorry, add 5 to both sides with the 10. So x is equal to 15. Now I need to figure out y. So I'm going to substitute 15 in for the x down here. 4 times 15 plus 10 is equal to 70. So this is a 70-degree angle here. This is a 70-degree angle here because those are congruent. And now I need to know the measure of this angle, 6y minus 4. Well, these two have to add up to 180 because they make a straight line. So 110 adds with 70 to make 180. So now I'm going to go 6y minus 4 has to equal 110 and get the y by itself. So I'm going to add 4 to both sides, getting those constants together. 6y equals 114. Then if I divide by 6 on both sides, y equals 19. Okay, number 3. Here we have parallel lines cut by a transversal. 11x plus 4 and 5x are called consecutive interior angles, so they have to add to make 180. 11x plus 4 plus 5x equals 180. So I'm going to combine the like terms. 11x plus 5x makes 16x plus 4 is 180. Now I'm going to subtract 4 from both sides. So 16x equals 176. And then I'm going to divide by 16 on both sides. So x equals 11. But that's not all. There's more. So if x is 11, this angle is 5 times 11. So that's going to be a 55-degree angle. Okay? And there's another pair of parallel lines cut by a transversal right here. And so this angle and this angle together have to add up to 180. So 13y minus 5 plus 55 equals 180. So 55 minus 5 is 50. And now I'm going to get my regular constant numbers together on the right, away from the y. So I'm going to subtract 50 on both sides. 13y equals 130. And then divide by 13 on both sides to get the y by itself. Y equals 10. All right. This is our last one, number 5. It says, find the value of each of the variables in the figure. Explain your reasoning. So the first thing I look at in a problem like number 5 is, where is the number that's actually filled in? 106. Okay, 106 is right here, and 106 makes a linear pair with 2y, so those have to add up together to make 180. So 106 plus 2y equals 180. So if I subtract 106 from both sides, 2y would have to equal 74, and then divide by 2 on both sides, y equals 37. So y is equal to 37, that's the first one. Now, this angle is equal to 74 because it's double the y, which we just divided 74 by 2 to get 37, so 37 times 2 gives us 74. This angle is 74, which means x is 74, because these are corresponding angles. So I know x is equal to 74. You could have also gotten that by saying 180 minus 106, because these are consecutive interior angles, and that would give you an x of 74 also. Now, x is vertical over here, so this one is also 74, and these two are consecutive interior angles. So together, they have to make 180. So 4z plus 6 plus 74 equals 180. 74 and 6 add together to make 80. And now I'm going to subtract 80 on both sides. So 4z equals 100. And then divide by 4 on both sides, z equals 25. So that was some fun with algebra. I hope that you have a lot of fun with your geometry homework, and definitely let me know if you have any questions, if I can help you in any way. See you soon. Bye.